Hey everyone, welcome back to another maths tutorial. In the last video we learned about distance-time graphs, which show us how distance changes over time. In this lesson we are looking at velocity-time graphs, which show how an object's velocity changes with time. These graphs look quite similar to distance-time graphs, so always double-check the labels. Velocity is on the y-axis and time is on the x-axis. To find the gradient of the curve at any point, we divide the change in velocity by the change in time. This gives acceleration. So on a velocity time graph, the gradient represents acceleration. If the curve has a constant positive gradient, like in the first section, it means the object is accelerating constantly. If the curve has a constant negative gradient, it means the object is decelerating at a constant rate. Let's calculate an example. In the first section, the velocity increases by 3 meters per second over 2 seconds. So the acceleration is 3 divided by 2, which equals 1.5 meters per second. Squared flat sections of the curve have a gradient of 0, meaning there is no acceleration. The object moves with constant velocity. To find that velocity, we just look at the y-axis. For example, during the second section, the velocity is 3 meters per second, and during the fourth section, it is 5 meters per second. When the curve gets steeper, the gradient increases, which means the rate of acceleration is increasing. 2. Now let's see how. To find the total distance traveled. The distance is equal to the area under the curve. For example, if we want the distance traveled in the first 4 seconds, we focus on the area under that section. We can split it into a triangle and a rectangle. The area of the triangle equals 1/2 times base times height, so 0.5 times 2 times 3, which gives 3 meters. The rectangle area equals base times height, so 2 times 3, which gives 6 meters. Add them together and we get 9 meters as the total distance traveled in the first 4 seconds. Although we are finding an area, we do not write the answer in meters squared, because the result represents distance traveled in meters. If the graph curve is not straight, and you only need to estimate the distance, you will usually be given a grid background. Each square on the grid represents a certain distance. We can then count the squares under the curve. For example, if each square equals 1 meter, and we count 6. Full squares plus a few halves, we can combine them and get about 8 meters of total distance traveled. So, to summarize, on a velocity time graph, the gradient equals acceleration. Positive gradient means speeding up. Negative gradient means slowing. Down flat line means constant velocity. And the area under the curve equals the total distance traveled. Thanks for watching. And don't forget to like, share, and subscribe for more maths tutorials.